taking notes. Okay. Case 2. So we did case 1 yesterday, so case 2 today. So case 1 was functions that are everywhere differentiable. Case 2 is going to be functions whose derivatives may not exist or may not exist everywhere. If there are values of x of which a first or second derivative does not exist, consider those values separately. Recall a local max or min. Can't spell local apparently. Tried to put an X and a C on the end of it.
Huh? X and a C at the end of local?
Yeah. I think I was thinking local max and then I don't know.
Yeah.
I'm not even going to try to explain myself. It's Friday. Is one of transition between intervals of rise and fall and an inflection point is one of transition between intervals of upward and downward concavity.
Okay.
I kind of like in person because you can like I feel like you can connect with them more.
Yes, I do. Does that say NSE? Between intervals of
Rise and fall.
oh.
What were you about? Oh, the word rise?
How it said NSE? NSE.
That's nice.
Yeah.
What
Yeah,
wasn't
that's
feeling
so
good?
sad.
I said something. I just decided, what a shame, we couldn't miss English.
What a shame.
Well, we didn't do anything.
We had a
so-
game
Nice.
day.
Nice.
We have vocab on Tuesday.
Yeah.
Just making sure.
Did Poetry Friday get moved?
Yes. Now it's 2 weeks behind.
You're welcome, guys.
So we're not gonna have the free day things, which is fine by me.
We
Not free day. I mean the extra bonus days that we have to do.
Yeah, some of them.
we just played that.
That's fine.
I'm glad I missed that instead of actual poem. 'Cause I like poetry.
No, I have some really good ones too.
All right, we're going to do an example of this. And I forgot there was one example we were going to look at that needed that step 4 from yesterday that I forgot we needed to start with. So we'll go back and do that after we do this one. Sketch the graph of y equals x to the 2/3. So we're still gonna find the derivatives like normal, the first and second derivative. So what is y prime?
Y prime is 2/3 x to the negative 1/3.
And then the second derivative,
Would be negative 2/9 x to the negative 4/3.
and just for visualization sake, I'm gonna use or move the negative exponents to the bottom. So this one would be 2 over 3x to the 1/3, and this one would be negative 2 over 9x to the 4/3. All right, so then we want to see where this derivative is 0. So is there anywhere that either of these derivatives are 0?
When x is 0.
It's 0 when x is 0?
No, that's undefined.
For what?
So is there anywhere that when we set this equal to 0 that we're going to have
Oh.
any x value going to give us a 0?
No.
No. Okay? So,
Yeah, I'm confused 'cause you want it here.
huh?
So it can't. It has to be any number other than 0 that would do it. Because when
Well, 0 on the bottom, if you plugged in 0 for x, it's undefined.
yeah,
I'm trying to figure out if I set this equal to 0, what value of x makes this 0?
the whole thing. Oh, okay.
But there's not one because of the way it is. So, neither derivative is 0. But both derivatives will fail to exist when x is 0. Because it's undefined, right? So now, this part of where this comes in is if there are values of x at which a first or second derivative does not exist, we need to consider those values separately. So now we're going to look at as x increases through 0, what happens to this. So if we start negative and we go positive, what happens as we go through 0? So if I put in, let's just say negative 1, what do we notice about this?
It's gonna be
Yes, negative. As x increases through 0, y prime changes from negative, or well, it may or may not change. And then when we plug in a, let's say 1 to this, what happens? So it does change. So negative to positive.
So do you always just plug in -1 and then 1?
I only did that because I need a number on both sides
Both
of 0. So like if it had been 1, I would have probably used 0 and 2 or something like that. I'm just trying to use easy numbers. I mean, we're looking at the stuff that's close by. We want to see what's changing about the sign so that it can help us determine if it's a max or a min. So, if it changes from negative to positive, what does that mean I have? A max or a min? All right. Who says max? Who says min? All right, 3 people didn't vote. Peyton, are you saying min?
Yeah.
Christian?
Uh,
If it goes from negative to positive, what do I have?
I don't know.
I don't know. Ethan?
That's like
A min? All right. It is a min. Okay. So as y prime changes from negative to positive, the point 0, 0, okay, so 0 was the problem point. If we plug in 0 to the original to get the other point of that, we just get 0. So the point 0, 0 is a min.
Never backed out from the answer. That's why I stuck with max.
Huh?
I never backed down from an answer. That's why I stuck with no.
Never back down.
Now, what do you notice if you plug in numbers to the second derivative? What do you notice to be true?
Like,
Um,
it's gonna be.
What's going to be the case no matter what number you plug
it's
in?
gonna be negative.
It's going to be negative, because even if you plug in a negative, it's being raised to the fourth power. If you plug in a positive, it's being raised to the fourth power, so the negative out front. So, y double prime is negative everywhere except at 0, obviously, because we said that's a problem area. Now, this part isn't going to come into play till much later, but because of that, the curve is concave down. But you don't need to worry about that just yet, because that's not until like 5.3 or something. So if we were to pick a couple points and graph this original equation, basically we have a min at 0, 0. So I've got a minimum there, and I'm doing it into x to the 2/3. So if I did like at -8, that would be like somewhere up here. If I did +8, somewhere up here. So this graph is going to be like this. It's going to look kind of like the birds that you know, draw in the sky. Yep. And that's why there's that problem area, because of the shape of that graph. Now, the official curve sketching part isn't until 5.3, but I figure it's good for you to kind of go ahead and see it because, you know, it's not that far away. All right, I'm going to go back and do a problem that's going to require us to look at that step 4. So we have, let me go back up to our steps from the other day. Find the two derivatives, locate any critical points, check the second derivative to see if it's a min or a max. If it fails, then we go on to step 4. And then we go through that process. So, this says sketch the graph. We probably won't do the actual sketching part. We'll just do the finding the information part. But f of x equals x to the 4th minus 4x cubed. So step 1, I need my first and second derivative. So what's the first derivative?
4x cubed minus 12x squared.
Second derivative?
12x squared minus 24x.
Alright, so now I want to find where my first derivative is 0, because that tells me what? What am I finding by doing that?
Critical point.
Critical points. So I'm looking for critical points. So I'm going to set 4x cubed minus 12x squared equal to 0. I can factor out a 4x squared. Oops. That leaves me with x minus 3 equals 0. So x equals 0 and x equals 3 would be my critical points.
And why is this one or 2, or is it and? Like, are they both critical points?
I mean, they're both critical points, but I mean, we always would say or. Because x can't be both values at the same time. That's why we say or. But they are both critical points. All right, so the other thing I will say with that step 3 where we're plugging into the second derivative to see if it's greater than or less than 0, or if it's equal to, then we have to continue to step 4. You could possibly have one of these points that you will know right away as a min or a max, and then one that's equal to 0, where we have to continue. So just know that, like, it doesn't have to be like both of them. And like, don't be like, well, one worked, so I don't need to check the other one. Like, you still need to do the analysis on the other one, kind of thing. All right, so step 3, we're going to evaluate the second derivative at 3. So that would be 12 times, I guess I could have done 0 first, I will. Minus, or 12 times 3 squared minus 24 times 3. And so what is that? Are you waving at me, Ethan?
36. Something double check on
36. So that means that, I don't know if that's right or not. I'm just going with
this. I
it.
don't know, I just kind of like tried to mental it.
It is 36. Wait,
All right.
negative 36.
Negative 36. It's negative 36.
Nope.
Or positive.
Oh wait,
It's not negative.
I forgot that was squared.
It's positive.
I was gonna say that can't be. All right, so
It's all even.
that means that f double prime of 3 is what to 0? Less than or greater than? Greater than, because it's positive. So if it's greater than 0, what does that tell us?
The original value
It's
is
a
a min.
min.
It's a min. So that means that,
Wait, would that mean that x equals 3 is a min? Or wait, what would be the min?
so the min would be, the x value would be 3. We need to find the y value from the original. So the min is going to be at 3, and if we plug 3 into the original, somebody's going to have to do this. 3 to the 4th minus 4 times 3 cubed. That's going to be the y value there from the original.
Wait, so where are you getting that equation 3 raised to the 4th minus?
This is the original equation.
Uh,
So the original equation is what I'm plugging this value in, because I know that I have a min at 3, but I need to know what the actual point is. And that is what 5.1 is including. Like 5.1 is doing, finding those.
Negative 27.
Negative 27. All right.
Yeah.
So that means that I have a min at the point 3 and negative 27.
yes.
So that's just the first point. So I need to check f double prime of 0. Which I already told you that one of them is, we're going to be required to do step 4, so you're probably going to know this one. But, so if I plug in 0 to the second derivative, I get 12 times 0 squared minus 24 times 0, which is
0.
0. So that means that the second derivative test fails.
Uh-oh. Fail.
Art.
So that means that I need to go through and check. So we don't know if it's a local max or a min, so I'm going to go through and use step 4. So I'm going to go up and re-look at step 4 so that we can see what we're going for. So if y prime of c is equal to 0 and y double prime of c is also equal to 0, then we're going to look at the signs of y prime, so the first derivative, as x increases through c. So basically, we're seeing what happens as we go from the left of the c value, or whatever that x value is, to the right of it in the original equation. And we're looking to see if it's changing direction. to see if it goes from positive to negative or negative to positive. If it does not change, then it's not a local max or a min. Like it's neither. So, all the way back down. All right, so into the first derivative, we're looking at what happens when we plug in something to the left and to the right of 0. And now if it had been 3, we would be looking to the left and the right of 3. We're looking at 0 because that's the point. So if I did like -1, value-wise, what am I getting here?
A positive number.
Yes. I was looking at the wrong side. So you get a positive number. What if I put in a positive 1? They're saying it doesn't change sign, but it definitely does.
It doesn't change what?
What did you say?
The book says it doesn't change sign, but it definitely does. So if we put in a negative, that's positive, and that would be negative times negative, which is positive. And if we put in a positive, that would be positive, but minus that, so it would be negative.
Yeah.
So it does change sign, so we're gonna have to, okay. So, anyways, it does change sign.
Dumb growth fucking authors.
It really is always good.
Like, why do you publish false information?
Even their graph, though. Is their graph wrong? Hold on. I'm gonna check something, because the graph, I will agree, it doesn't change sign when you look at the graph, so that's why I'm like, are we looking at the wrong thing here? Next.
So why did we get rid of the song part? Are we adding a song?
We were trying to see if we can be a million good. Is that your Josh?
Trying to.
Trying it one more time.
Yeah, because maybe since it's not for graduation this time.
I guess it's kind of.
Well, it was-
She's bringing up the idea. We're not.
Fine last year for middle school.
Yeah. It
Or
just wasn't
elementary,
fine
whatever.
for graduation.
I
Since
guess
it's a
I guess
concert.
he's kind of picky. Wasn't the reason he's picky for songs on graduation because he said like
Yes.
at graduation there's not a lot, there's a more chance that there being
Yeah, yeah.
I just realized something.
What did we do?
Did you write it wrong?
No, we plugged it into the original. It's supposed to go into the derivative. I was like, I don't understand. And then I was like, wait a
With
minute,
the
let me
first
look at this
derivative?
again.
Wait, we
Or the
plugged
It's
in
supposed to
what?
go into the first derivative.
Oh.
So if we,
that would be why.
yes. So we need to look at the sign of this to see what happens.
Oh.
So if we plug it into the, I'm just going to cover up the original. So if we plug in -1 here, what happens?
Then it's negative.
Yes, it's negative. If we plug in a +1, what happens?
It'd be-
Negative. So,
Mhm.
yeah, see, that's the thing. I'm telling you, you got to pay attention to what you're plugging stuff into. And I was just like, oh, yeah, the original. So the sign does, it does not change sign. As x increases through 0. So, if we plug in 0 to the original, we get 0, so that means that the point 0, 0 is neither a max or a min. Now, depending on what the questions ask you, you may not need to do all of this stuff. Like the question, if it just says what are the max and mins, you don't necessarily have to write all of this information. You're just looking for what is. So you don't necessarily need to be like, well, this isn't because blah, blah, blah kind of thing. You
So
just,
say
you
why.
need to like check it yourself, but you don't have to like write all of the stuff down unless it's asking you for that. What was step 5? I think it was something about points of inflection.
Yeah.
Find all x values where y double prime is equal to 0, and then check the sign as the sign of the second derivative changes. So, where is the second derivative equal to 0? That's what we need to see. So, that was 12x squared minus 24x. So I need to see where that's equal to 0. So I take out a 12x, leaves me with x minus 2. So at x equals 0 and x equals 2 are the possible points of inflection. So we need to look at, in the second derivative, when we pick a number to the left and right of it, we need to see if it's what's happening, if it changes, increases, or whatever. So if it is -1, what happens? Positive. And then if it's 1, it's negative. So it does change sign. So f double prime, or we'll say y double prime, I guess is what we've been saying. Or no, I guess we haven't been saying it. So f double prime changes sign. As x increases through 0. And it went from positive to negative, just in case. Do you see this? It literally made a little thought bubble when I wrote an N.
I do see that. What
Thought bubble.
is
Oh, I didn't know you did that.
I didn't either. I didn't know I did it.
Can you do it again?
Well, I mean, maybe, maybe not. Sort of. Almost. And then what about 2? If we put in 1, what do we get?
Negative.
And if we put in 3, I think it's positive. So, and x increases through 2. It goes from negative to positive. So the point 0, 0, even though it wasn't a min or a max, it is an inflection point. And that again came out of the original. And then 2, we need to see what 2 is in the original. If I plug in 2 to the original up here, what do I get?
Oh, you know, some good.
Is it negative
Oh, wow.
16? Okay. So 2 and negative 16 are points of inflection. All right. So I think we're ready to go back to the last few problems in the book that we need to do.
Yeah.
All right. So the last problems that we need to look at say to find the extreme values of the function and where they occur. So when it says and where they occur, that's asking for the point. Okay, so the other problems that we did from the book were just asking like where the min was, and it was like, or the max, and it was like at x equals blah blah blah. But now we actually need the point, like we've been finding
Oh, okay.
with these other examples. Let's see. 22. Y equals x cubed minus 3x squared plus 3x minus 2. So I'm going to more or less follow the same steps, but I'm only looking for the stuff that I actually need. I'm not doing like all 5 steps if I don't need it. Does that make sense?
Okay.
So y prime is
3x squared minus 6x plus 3.
and I'm gonna do y double prime over here in case we need it. Y double prime is is that what you said? Okay.
So we might not need it.
Well, I mean, typically we are gonna need it for finding the min and max, but I guess what I really should have said is so that I can work under here to factor it out, since it's not something that I can like easily see.
Okay.
That's really what I should have said. So I can factor out a 3. I know I need to set this equal to 0, so I'm going to go ahead and factor out a 3, which leaves me with x squared minus 2x plus 1. And that's going to be equal to 0. So that means that I've got x squared minus 2x plus 1 equal to 0. And what does that factor into?
X plus 1, x minus 1.
That would be a difference of squares. It says a special type, though.
It's a perfect
X.
square trinomial, right?
X minus 1, x minus 1.
X minus 1 squared. So that means then that x is equal to 1. So now what?
We have to see if it's a min or max.
So I'm going to evaluate the second derivative at that point and see what happens. So, oh no.
Oh no, what?
I'm just seeing what's going to happen.
Oh.
So f double prime, I'm going to just switch it to f double prime so I can put it in the point of 1 would be equal to 6 times 1 minus 6, which is
Oh.
0. So what does that mean?
Womp womp womp.
Womp womp.
Second derivative test failed.
And it failed. So that means if we would, yeah.
So that means I've got to go to
I'm okay with
Step
failing.
4.
step 4 and see what happens to the sign of the first derivative as we go through that point. So the first derivative as we go through 1, so if I put in 0, what happens?
You get positive.
Is positive, and what if I do 2?
You get.
You get positive.
Positive. So the sign didn't change, so that means what?
You gotta do the second derivative.
We already did the second derivative. What happens when the sign doesn't change? What happened in our last example?
There's no min or max.
Right. So the sign of y prime did not change. So there's no min or max. So now on the other problem, we did have a min, I think it was. Yeah, we had a min, but the second point we checked was not a min or a max.
Okay.
So in this case, there was only 1.2 check, and so there's no min or max for this problem because there was only one to check.
Because we only have the x equals 1.
Yeah. And so if we had plugged 1 into the original, we could say the point the point 1, -1, or whatever it is not a min or a max. But since there was just none, we could just say no. Like the book just writes none instead of explaining all of that. So anyways. Let's see, 24. Y equals 1 over x squared minus 1. So what's my first step?
Derivative.
And what am I dealing with? Quotient rule. So what is my derivative going to be? It's been a while since we did a quotient rule.
U prime plus
The other way.
Is it, oh,
Derivative of the top times the bottom.
so u prime b minus ub prime over b squared?
Yeah.
so negative.
I always have to write it.
What would be
So the first thing would be 0, so we've got to write the minus sign then on top.
2x
So that's the second part over.
x squared minus 1 squared.
And second derivative.
And
Yeah, so let's get
negative 2 times.
You sound so excited.
Oh, is that a chain rule?
Well,
Well, not
I'm
yet,
just
'cause you don't
copying
have
it
to do
down.
that.
Oh, yeah, that's right.
Minus.
Or plus. Oh my gosh, let me just go ahead.
That's so depressing. Step.
All right, what's the derivative of the bottom part?
Goodness. Okay.
2 times x squared minus 1 times 2x. All over.
I'm gonna just leave it right there because ultimately we would be plugging in a number anyways. So instead of trying to simplify this down, I would just leave it because if you need to plug in a number, you can do that a lot easier than trying to simplify this. I just wanted to rewrite that so it looked a little neater. Or actually, that's supposed to be an x cube. No, x squared. All right, so I need to find out where this is equal to 0.
It's equal to 0. When?
When I have a fraction and I'm setting it equal to 0, what's the only way for it to be 0? If what's 0?
The top.
The top. The bottom, the bottom's just gonna go away because if the bottom is 0, it would be undefined.
So x is
Right.
0.
So we would have negative 2x equals 0, so x equals 0.
So the only reason that would work is because there's an X on the top. So if there wasn't an X on the top, then 0 wouldn't work.
Right, then we would have the same situation we had in that first example earlier, where we had the X's on the bottom only. So that means now I'm going to check what?
Your second derivative.
Second derivative at that point. So f double prime of 0
Oh my goodness. It's not gonna be so. Wait, 0.
correct, it won't be.
Yeah, no, because like,
This part will be.
That will be 0.
This part, I'm just gonna do this. We'll go to 0 when we plug in 0.
The
Mhm.
first part is gonna be -2. Right?
Yes. What about the bottom?
yeah.
The bottom is going to be 1.
So that's equal to -2, which is what?
It's less than 0.
Less than 0, and what does that mean?
It's a max.
So we know there's gonna be a max
Oh, we know there's gonna be max. So it's not.
at
Oh, wait.
the point 0, and we plug in 0 to the original. When we plug in 0 to the original, we get
-1.
-1. So we have a max at 0, -1.
I really thought long and hard about
We're just not even here anymore.
Hold on. Before we work a whole problem, I'm gonna see what the answer is supposed to be so that I know if it's worth doing it or not. Yeah. Sure. What is this 5.1? What are you doing? Wow. Cold day for that.
It happens to be every time I go. There's like 40-mile winds.
I haven't been to Christmas Town in a long time. I was gonna go this year, but I didn't after a fun time.
That's usually our problem. I think we ended up going 3 times though. But that's mainly because we like were intentional about it because like Catherine came down, so that was why.
That makes sense.
If she hadn't, I don't know if we would have gone that much. What in the world happened?
What happened?
What?
What is that?
That's what it was supposed to
I'm
be.
a little worried.
If y'all want to go ahead and find the first and second derivative, you can. I'm gonna fill up my water, and then we'll actually solve it when they come back.
What was that? Where'd they go?
They went to the bathroom.
Oh, when did that even happen?
You guys are gonna have fun with this problem. I'm leaving in 2 minutes.
Where are you going?
Class is over.
Oh. Wait, well, I'm not gonna do this problem when class is over. I'm not doing this later.
Anyways, you guys are gonna be nice to me because we have.
No, we're gonna get stats class.
Well, I was waiting for y'all to come back.
We only have 2 minutes, apparently.
What?
Yeah, it's
Oh
1:23.
man.
I know. Christian was like, "Y'all can do this. I'm leaving." I was like, "Why are you leaving?" He was like, "Class is over." And I was like, "Oh."
Oh man. a good problem too.
Good is subjective.
Okay, well, we might finish this on Monday, but I'm gonna go ahead and give you your problems because we need to start 5.2 on Monday.
Yeah.
But you should be able to do most everything aside from this. I guess we're taking a long break. Okay. 1 through 9 odd. And oh, I don't have problems already pulled. Let's see. 11. 17. 19, 25, and 27.
You're
May you
certified personal
post these
finance
next
now.
videos?